a design is required for a CS amplifier for which the Mosfet is operated at GM is equal to 5 milliampere per voltage and has CGS is equal to 5 picofarad and CGD is equal to 1 picofarad. The amplifier is fed with a signal source having Rsig is equal to 1 kilo ohm and Rg is very large. What is the largest value of RL prime for which the upper 3 decibel frequency is at least 6 megahertz? What is the corresponding value of midband gain and gain bandwidth product if the specification on the upper 3 decibel frequency can be relaxed by a factor of 3, that is to 2 megahertz? What can AM and GB become? Okay, so first part of the question, they are asking for the what value of the RL prime. At what is the value of RL prime at which point 3 decibel frequency is at least 6 megahertz. Okay, now let's try to do this. So in order to do this one, we have to know the expression for the frequency, that is given by fh is equal to 1 over 2 C in Rsig. Okay, so here we have we have to solve for the C in because that is required to find the RL prime later on. So here, in order to solve for C in, we have to just plug in all the values provided. Here fh is provided to be 6 megahertz, so 6 mega right here, and then that is equal to 1 over 2 pi. C in is what we are trying to solve, and Rsig is provided to us, that is 1 kilo. Okay, rearrange then solves for C in, which gives us 26.53 picofarad. Okay, now once we have solved for C in, there's another equation for C in that is given by C in is equal to CGS plus CGD times 1 plus GMRL prime, and the question is asking for the RL prime, and everything except that is available. We just solve for C in, that's available to us, and CGS is provided in the question, that's 5 picofarad. CGD is provided in the question, that's 1 picofarad, and GM is also provided in the question, that is somewhere here. Let me see. Yeah, that's 5 milliampere per voltage. So we have all the information available except RL prime. RL prime is what we are trying to solve. Plug in all the values. C in, we just found out 26.53 picofarad, and then CGS is available to us, 5 picofarad, and then CGD is available to us, that's 1 picofarad, and then GM is available to us, that's 5 milli times RL prime, and if you rearrange and solve for the RL prime, you will end up getting 4.11 kilo ohm resistance. Okay, that's the first part of the question, and the second part is asking what is the corresponding value of the midband gain and gain bandwidth product. Okay, so when they ask for the midband gain, it's basically the frequency they're asking for. So in order to calculate that, first we have to know the AM. AM is given by negative Rg over Rg plus Rsig GMRL prime, and for a midband gain, this is 0, so this is going to be negative Rg over Rg. This Rsig is 0, so negative Rg over Rg GMRL prime. Rg over Rg become 1, so this is going to be just negative GMRL prime. That's our AM. Okay, and AM is the midband gain. Okay, so we have to just plug it in the values. We already have it. AM is minus GM times RL prime. GM is provided as 5 milli right here. RL prime, we just solve for it, 4.11 kilo ohm resistance. Plug both of them in. 5 milli and then 4.11 kilo ohm resistance, and that will give us negative 20.55 voltage per voltage. This is the midband gain, and the bandwidth is frequency, so we have to find out of ft, which is am times fh. Am in the absolute value, so this is going to become positive, so 20.55 times the fh, that is the highest frequency, that is 6 megahertz upper limit. Okay, multiply both of them, and this one is okay, 20.55 times 6 mega, that will give us 123.3 megahertz, and that's our bandwidth. Now the next part is asking if the specification on the upper 3 decibel frequency can be relaxed by a factor of 3, that is to 2 megahertz, what can AM and GB become? Okay, so they are asking if it's relaxed by 3 decibel, what's going to be the new midband gain and also the bandwidth. Now in order to find out that, again this equation is going to be the same. First we have to calculate the Cn. So here if it's increasing by factor of 3, then what we have to do is we have to increase this one by a factor of 3 and also multiply by 3. So this Cn becomes 3 times this 26 becomes 29 right now because we are increasing 3. So 29.53 picofarad, and which will give us 79.6 picofarad. And once we have this one, we have to find out AM. In order to find out AM, we need to know the RL prime. So to find out the RL prime, we have to use this equation right here. Again, Cn is equal to CGS plus CGD times 1 plus GMRL. Okay, Cn is 79.6 picofarad, and CGS is 5 picofarad, CGD is 1 picofarad. Plug that one in. 5 pico plus 1 pico, and then this is 1 plus GMRL. 1 plus GM is 5 milli times the RL prime is what we are trying to find. Okay, rearrange and solve for this one. You will end up getting 14.72 kilo ohm resistance. And once we have this one, we can find out the midband gain, that's AM, which is given by negative GMRL prime, and GM is nothing but 5 milliampere per voltage, and then RL prime we just calculated that right here, that is 14.72 kilo ohm resistance. Milli and kilo cancels each other, and we will end up getting negative 73.6 voltage per voltage. Okay, this is our midband gain. Now to find out the bandwidth, this equation we have to use. Ft is equal to AM times Fh. Ft is equal to AM times Fh. Okay, this is absolute value AM, so whatever the midband gain we have to, this is going to be positive, so this is going to be negative 73.6 right here. And then Fh is nothing, Fh is different right now. In it, previously we had 6 megahertz, now they are saying 2 megahertz, so that's the one we have to plug it in. So here this one is 2 megahertz, and if you plug it in, you will end up getting 147.2 megahertz as the bandwidth. And that's it for this question. I hope you guys found it helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.